As the title suggests, this isn't all mathematics and physics. This, well, whatever you call it, video thing, is all in my own words, explaining or even oversimplifying theories and hypotheses, with the exception of some definitions and precise details. Quick overview on time travel. The Oxford English Dictionary defines time as a limited stretch or space of continued existence, or as the interval between two successive events. The widely accepted view on time is that it's relative. For example, if time was a balloon, the skin is the present, the space inside it is the past, and the space outside it is the future. But for someone who's inside the balloon, or if you prefer, the balloon just has less air in it, that point where they stand is the present, while the point where you stand is the future, and you see your point as the present and them as the past. But this view of time is using relativism, which is the idea that some elements or aspects of experience are relative to or dependent on other elements or aspects. Definition of time travel. Hypothetical or fictional travel at will to the past or future, typically by means of a machine, a time machine, or a wormhole. There are many theories surrounding time travel, but surprisingly, most interest is focused not on how time travel is obtained, but on if, and what would happen if, time travel was obtained. Another way to use the statement time is relative would be to refer to the theory of relativity, which is really two theories, which is special relativity and general relativity. Special relativity says that the laws of physics are the same for all observers in uniform motion relative to one another, and that the speed of light in a vacuum is the same for all observers, regardless of their own motion, or of the motion of the source of the light. For example, if something emitting light was moving, everyone would still see it the same. Or the people seeing these light sources were moving, they'd still see it the same way as each other. Consequences referring to time for special relativity are time dilation, which is moving clocks are measured to tick more slowly than the observer's stationary clock, and the mass-energy equivalence, which is E equals mc squared, which I'm going to discuss later on. And the other half of the theory of relativity is general relativity, which basically proposes that space-time is curved. And the consequences of general relativity that are related to time that I can pick out are time goes more slowly in higher gravitational fields, which is gravitational time dilation. To leave physics alone for a while, I'm going to talk about something that science fiction has always sort of pondered and played with, which is the idea of paradoxes. An example of a paradox is the classic grandmother paradox, where a time traveler kills his own grandmother. Thus, he was never born, therefore he wouldn't have went back in time, meaning that he was born, went back in time, and killed his grandmother, and so on in an infinite loop. Most scientists agree, though, that paradoxes would never happen. One theory is that the past is totally defined, everything that has happened must happen, and that the past can never be altered in any way, shape, or form. For the example of this grandmother paradox, the time traveler would experience infinite mishaps in the attempt of killing his grandmother, thus keeping time intact. But to refer to the movie Click, the main character can only, when he rewinds his life, he can only view it, but he can't change it. So I think that's pretty accurate and on track with what scientists agree. And another main theory on paradoxes, which is kind of more complicated, is that if and when you make a change, in that very that very moment, that very split of time, you create a parallel universe, and then you will be part of that universe. So, for example, if you kill your grandmother, you will break off into this new universe in which she never lived, and thus you never. I have no clue what's going on with my microphone. It keeps cutting me off, and just ticked off. You yourself will break off into the new universe, erasing yourself from that universe, so you never existed ever, and neither did your grandmother. But the other universe does stay intact. It stays that she lives and you live. So in the idea of creating a new parallel universe, it's kind of like creating a new destiny, which I'm gonna discuss a little later on, of the universe, in which she was meant to die and is a definite event, which kind of ties the two theories together, which I think is pretty cool. Yeah. Destiny! One hypothesis on backwards time travel is that any changes made to the past must have been part of history all along, including the time traveler, for example, killing a baby with a silver hammer, unknowingly fulfilling the correct event in history, even out of his own time. But this idea is also often called destiny, and is shot down quickly with the common sense that people create their own destiny. To the past! The most common hypothesis concerning how to travel backwards in time would be to move faster than the speed of light, which would involve Einstein's famous equation E equals mc squared, which means that energy equals the mass times velocity of light squared. And it shows that as an object approaches the speed of light, the energy of that object that's moving gets applied to the object's mass, making it harder and harder to increase its speed. And as the object approaches the speed of light, its mass becomes infinite, and the energy that it would take to accelerate it further would also become infinite. And light waves travel at this speed because they have no real mass. But this theory, when pushed to its limits, does not really prohibit time travel at the speed of light. It just says that it would be really, really hard. And we must remember that the laws of physics tell us what's possible, not what's practical for humans at this point in time. The thing with moving faster than the speed of light, though, is that you'll get time dilation. And you'll even get time dilation if you're not moving it faster than the speed of light, even just traveling at a high velocity. For example, if you put a twin on Earth and another twin on a spaceship, and the one twin is moving faster than the other one because the other one's on Earth, and the one is moving faster, when the twin on the spaceship comes back, he will be younger than the twin who stayed on Earth. Same thing happens when you're moving faster than the speed of light, or near the speed of light, because the faster you move, the slower time goes. And as you approach the speed of light, which usually has the variable of c, time pretty much stops. And can you go faster if time has stopped? And say you do go faster, the variable c will become negative, and time will start to move backwards. And that's how moving faster than the speed of light is traveling back in time.